Hello everyone, welcome to the video solution of computer-oriented numerical methods. Today we will solve the second internal test of CONM. The test paper contained 5 questions. We will solve each and every question. Moving on to the first question, what is partial pivoting? Write pivotal condensation algorithm. Pivot is a diagonal element that one uses during the elimination procedure is called pivot. Partially pivoting is a technique that is used to avoid round-off errors that could be caused when dividing a row by an entry that is relatively small in comparison to the remaining row entries. Partial pivoting: for each new pivot column in turn, check whether there is an entry having a greater absolute value than the column, the current pivot row. If so, choose the entry among these having maximum absolute value. Then we choose that with the row to place the chosen entry into the desired pivot position. In pivot, in pivoting, we choose a column. Uh, we choose the maximum absolute value of a column for a system of equation, and we check all the rows. If any entry is having maximum number greater entry than the maximum number, we will swap the rows. In partial pivoting we can swap the rows only, and in complete pivoting we can swap the row as well as column. Moving on to the pivotal condensation algorithm. In this I have explained the algorithm in short. We can read that: start. For each column in augmented matrix, find pivot element in each current element. Swap current row with row containing the pivot element. For each row below the current row, subtract a multiple of current row to eliminate the coefficient below pivot, and stop. I have also linked the algorithm which is required for the computer application. Here we have chosen a max element, and we have assigned AKK as the max element. We have also assigned K as P. We have carried a loop from m equals to k plus 1 to n. Here we will check the condition. If AKK is greater than max, then we have to assign AKK to max and m to P and then end. And if max is greater than equals to E, then we will consider it as ill-conditioned equation. Else if P equals to K, we will exit to number 3. For K equals to Q to n plus 1, we will assign AKQ to a temporary variable, APQ to AQQ, and temp to APQ, and then we will end the for loop. Here the first question come to an end.